Okay. Welcome everyone to this masterclass about Wikibase and question answering. I'm very happy to be here to present. Oh, it's a bit echoing. For the first time at the Knowledge Graph conference. I'm Dennis Diefenbach from the QA company. We are a company specialized in semantic technologies and also in question answering. And this is why this combination between Wikibase and question answering. So the talk will be structured as follows. In the first part, I'm going to describe a bit what Wikidata and Wikibase is. Probably most of you do not know Wikibase, but know Wikidata. So we will start from there. In the second part, I would like to motivate why Wikibase could be a good infrastructure for knowledge graphs. Then we are entering more hands-on session where we would like to construct a knowledge graph about the Knowledge Graph conference itself, since we realized yesterday that we do not have one. And at the end, I will do some QA because we are from the QA company. So I will show you some QA on top of it. So Wikidata, Wikibase. Let's start with Wikidata. The MediaWiki Foundation, this is the logo of the MediaWiki Foundation, hosts many different wikis. The most known is Wikipedia, but there is Wikivoyage for traveling, Wikimedia Commons for images and media, Wikispecies, Wikidictionary, and one of them is Wikidata. And Wikidata is the one that we are interested in today because basically it is a knowledge graph. Everyone knows Wikipedia, but in fact, Wikidata is the wiki in the ecosystem of the MediaWiki Foundation that receives most of the edits, even more than Wikipedia. And this is how Wikidata looks like if you have never seen it. So basically, this is the article in Wikidata about the Knowledge Graph conference. So we have the main title of the page, the Knowledge Graph conference. We have an identifier for it, which is 8 million something. Then we have different sections in each page. In the first section, we have the description. We have how this entity is basically called in different languages. For example, we have here that in English it is called Knowledge Graph Conference. We have a description, conference series, and we have this part that indicates alternative labels for this entity in the graph, which is KGC, the Knowledge Graph Conference. In French, we have, for example, that the description is série de conférences. Then we have a next section, which is about the statements, which are in fact the facts about this entity. And we have, for example, that it is an instance of a convention series. It's a subclass of a convention. It was founded in 2019. Its short name is KGC. It was founded by François Schaffer and Thomas Delay. It is generally held in the United States. Its main subject is knowledge graphs. We are speaking English at this conference, and this is the official website of it. So this is information that is in Wikidata about the Knowledge Graph conference. It's not something that I put in, it's something that the community over time accumulated. And then we have the last section, which is the identifier section, which is basically pointing to other websites on the web that might describe this entity. And in case of the Knowledge Graph conference, we have a pointer to the Instagram page of the Knowledge Graph conference, to LinkedIn, to Twitter, and to YouTube. Okay, so we have seen that Wikidata contains the Knowledge Graph conference, but in fact, Wikidata contains so much more. It contains, in fact, generally whatever you can think of. Books, artists, films, proteins, stars, chemical compounds, sites in New York. Really, there is a lot of knowledge there. There is more knowledge, there are more entities described in Wikidata than in Wikipedia. So to show you a bit how fine-grained it is, I would like to give you 3 examples of entities that are there in Wikidata and that you might not have expected. So the first one is Cornell Tech, which is the place, in fact, which we are. And we see that there is an article with quite a bit of information about this entity. And Cornell Tech is maybe not the most known site in New York. So you can imagine that about New York City, there are many, many other sites in Wikidata with a lot of data. There is myself in Wikidata. It's not something that I created. It's something that the community contributed to. And also here, there are quite a bit of facts about myself. And here again, so I do not have a Wikipedia article. I'm not that famous, but I have a Wikidata entry. And you can imagine that many people at this conference, in fact, have a Wikidata entry, and maybe you do not even know. And finally, there is this entry in Wikidata, Q endpoint to Wikidata Sparkle endpoint on commodity hardware, which is a publication that we made very recently. And also this is a piece of information that I didn't input it myself, but the community did. And this is pretty astonishing because we are saying in this article, it is an instance of a conference paper. There is this title. The main subjects were extracted from the publication. It is about Wikidata and Sparkle endpoint. They are the authors, and the authors are disambiguated towards the graph. So he's pointing really to my entry in Wikidata here. And it was published the 30 April 2023. So basically this paper appeared the first time 8 days ago, or 9 days ago, and it's already in Wikidata, which is, for me, it's really astonishing. And I really didn't put it. Okay, so maybe to give you some more arguments how big and how fast Wikidata is, here are some statistics. In the month of April, Wikidata was accessed 40 million times. And these are the page views. So people over the world, 250 million times accessed a page of Wikidata to check some content, to edit the content, or just to do something with the data. This was done on 3 million unique devices. And just in the May of April, there have been 21 million additions to this graph, which is huge. In fact, on the May of April, 2,000 new users joined the Wikidata ecosystem. Just in 1 month, 2,000 users. And in the May of April, there were 12,000 active editors. So 12,000 people around the world went to the graph and made considerable edits to the graph. This is why they appear basically in this counting. And 10 million pages were edited. And in general, we have 8 gigabytes of data that flow in, flow out in Wikidata in the month of April, which might not be so much, but if you consider that it's raw structured data, it's not images or audio, it's quite a bit of data. Okay, so what is now Wikibase? So if you think about Wikidata, then you generally think about the data. But in fact, behind Wikidata, there is a software, and this is Wikibase. Basically, Wikibase is the software that runs behind Wikidata and makes all these things possible. Wikibase is an open source software, as each software of the Wikimedia Foundation. This here is the official website. And in fact, it is maintained by a chapter of the Wikimedia Foundation, which is Wikimedia Deutschland. So it's mainly developed in Germany. And so it's a free software. So it is there. You can find a GitHub repo, and especially you can install it locally. So you can reuse all the software that is in this ecosystem to run on your local instance, something like Wikidata. It's not only like this. It's not only that the code is just there and you can, you have to struggle to basically to install it or to find it, but there is really also an interest from Wikimedia Foundation to make this a standalone software. And in fact, there exist 2 versions. One is Wikibase Suite, which is meant for on-premises installation. And the other one is Wikibase Cloud, which is more a cloud instance version, which is currently in beta. So the makers of Wikidata, of Wikibase, really are driving this as a product, as a standalone product. And the general idea is not to have only Wikidata, but to have Wikidata and many Wikibase instances around that are federating and basically are hosting other types of data that are not necessarily of general interest. Okay, so now I would like to motivate why Wikibase could be a good choice for an infrastructure for knowledge graph. One of the arguments I already brought, which is Wikidata itself. Wikidata is a very, very successful knowledge graph. You see it contains a lot of different entities, a lot of different properties. Also, it is highly edited, it is highly used, so it is successful. It is run by Wikibase, so this could be already a good argument to use Wikibase as an infrastructure for your own knowledge graph. Besides Wikibase, there are also other instances. Besides Wikidata, there are also other instances. For example, we maintain the EU Knowledge Graph, which is a graph from the European Commission that also uses Wikibase as an infrastructure. But there are many museums and other public and private institutions that use this software to basically host their knowledge graph. Besides this, I think there are different arguments why Wikibase could be a good choice for an infrastructure for a knowledge graph. First of all, it is user-friendly. So if you look at Wikidata, basically you do not see any RDF. You do not see any sparkle. You just see this user interface, and this user interface was never meant to be used by expert users. It was always meant to be used by people that do not know what a knowledge graph is and also do not want to know what a knowledge graph is. So the information is relatively self-explained, and you can edit it easily, you can add information. So yeah, and we see it because so many people of so many different backgrounds basically tackle and edit this graph. Another argument is that it is highly collaborative. So we have seen that in Wikidata, thousands of users edit the knowledge that is in Wikidata. But if you think about an organization or an institution, then also generally you want to have one knowledge graph, but the knowledge that is in the knowledge graph is something that is created across the organization. It is in the head of the many people. And all these people basically have to bring this knowledge into a knowledge graph to structure it. So generally a knowledge graph construction in an institution is a collaborative effort. It has a graph structure. So this year is the Knowledge Graph Conference. It's the same entity as we were seeing before. So we see that it has as a main structure, as a main subject knowledge graph. We could go here. We could further explore it. It's a facet of computer science. If we go back here, we see that it's in the United States. If we go to the United States. Anyway, so it has a graph structure, as we know, and since we had a knowledge graph conference, we cared that it has a graph structure. But also it has a main reason that it has a graph structure, because it's impossible to otherwise organize this knowledge in a different data structure. It can be queried in the sense that maybe until now, when you thought about Wikibase, we thought, oh, there is this user interface that resembles Wikidata, but in fact, the query service is also part of Wikibase. So Wikibase is not only this input field for putting the data, but it's also this. And so the data can be queried, and this is a query that basically retrieves from Wikidata all the series of the Knowledge Graph Conference. We have seen before that it was founded in 2019, so we have the 2019, 2021, 22, 23 edition here. In this architecture, we have full track of changes. So if we go back to this article and then we go to view history, basically we see how the knowledge graph was created over time. So it started on the 3rd of March 2020, when this user created the item knowledge graph conference. And then it was constructed over time by different users and by different contributors. And this is very important, and it's generally rare in a knowledge graph infrastructure, because if multiple users basically edit it, you always want to keep track where the knowledge comes from. Either because you want to speak with this person, or because you want to point out that there is some mistake there in his data modeling. And so knowing how the knowledge graph evolved it's a very important thing. Another argument is that it can be edited both by humans and by bots. So if we go back to the history, we were seeing before an edit that was made by a normal user. But if you check the history here, there is a borked bot. And there are many of these bots in Wikidata. And this borked bot is a particular bot that is running over Wikidata over time. And the only thing that it is making is that it is checking the Twitter statements and is adding metadata about this Twitter statement, and in particular, this Twitter user numeric ID. So while there are people editing Wikidata by hand, Wikidata is also editing highly by bots. For example, the publication that I was showing before, I'm sure it was not a human who edited. There is a process that is community-driven and that is basically ingesting these publications over time. Another argument is that it scales well. So Wikibase hosts Wikidata, and Wikidata is one of the largest existing knowledge graphs that we know. It contains 17 billion triples. It's pretty large, and it's not so easy inside of an organization to reach basically this volume. And also, if you think of Wikidata about all the things that are inside before you have an organization that basically has so many concepts that it needs to model, you really will barely arrive at this size of data. It is multilingual. So while we see it here in English, everything was designed to be multilingual. So you can switch the language, then you would see this entity basically completely from the Spanish point of view, from the French point of view. So you will see the same data, but in another language. And this is also cool, because if you imagine there are people in Spain and there are people in US, and they are editing the same knowledge, but they are not even speaking the same language. And that's kind of crazy that this is possible. And but it's also something very native and very underlying of a knowledge graph, because we model the knowledge and we do not model some language or some strings. Okay, so maybe some use cases of Wikibase. So one I was saying before is the EU knowledge graph. This is a graph that we maintain for the European Commission, and that uses Wikibase as an underlying infrastructure. And this graph contains information about institutions of the European Union, countries, capital, head of states, ministries from the European Commission with their related information, 1.8 million projects that are financed by the European Union in Europe. We have beneficiaries of these projects. We have statistical territorial entities, so all regions in Europe are basically organized in this graph. We have buildings, canteens, cafeterias, parking owned by the European Commission. The EU knowledge graph is used as a linked data catalog. So basically, if you have a tool which is about linked data, I don't know, a triple store, a visualizer, and so on, then this graph is also meant to make a catalog of these type of solutions. And if you have a solution that you think is a linked data solution and you would like to increase its awareness inside the European Commission, because maybe at some point they are searching a tool like this, you can basically go to this graph, add your linked data solution, and add it to this catalog. Very recently, there was an initiative to make a catalog to add Sparkle endpoints. So there was not really a collection of public available Sparkle endpoints, and now the EU knowledge graph is also used as a catalog for Sparkle endpoints, where there are addresses of different Sparkle endpoints, how much triple they contain, Yes. This is an open knowledge graph. So we have a talk about the EU knowledge graph itself on May 11 at this conference if you are interested. But otherwise, you can think in any domain. So we are hosting also knowledge graphs for other private institutions. There is a lot of activity in the GLAM community, galleries and museums, that basically use a Wikibase. And you can think of use cases in automotive, pharma, whatever you would like. Okay. So now the goal of the masterclass, together with you, is to make a knowledge graph about the Knowledge Graph Conference, and we try to make as good as we can, given the time. And but yeah, so we do not have a knowledge graph about the Knowledge Graph Conference. It's a bit of pity. So maybe let's think together how it could be done. And yeah, so we drafted something, and then maybe there is a part where you can edit and we can discuss. So first of all, we need an infrastructure. So we brought a Wikibase. We brought a Wikibase, which is available at kgc.theqacompany.com. This is a place where you can go and try to access this Wikibase instance. This would be important for later. So it's knowledgegraph-conference.the-qa-company.com. And basically what we did there is that we took Wikibase as a software. We install it locally. We are running it on a server. And yeah, so we want to use this as an infrastructure for our knowledge graph. So first of all, let me give you a small introduction about the environment. So if you go to the page, it looks like this. So it's a typical MediaWiki installation. And it has this Wikibase extension enabled. So basically, if you go to Q1, then you see the Knowledge Graph Conference. I mean, we want to model a knowledge graph about the Knowledge Graph Conference, and if we don't have the concept of Knowledge Graph Conference, then we are lost. So Q1 is Knowledge Graph Conference. It's the first concept that we can use to basically model our knowledge. And here you see it looks like Wikidata, but it's not Wikidata. A second thing is that this Wikibase has its data exports. So the data exports are available under data.kgc.theqacompany.com, and they look like this. And if you are used to Wikidata, in fact, the Wikidata exports look exactly like this. So there are these full dumps and there are these truthy dumps. And what I just want to say is we are trying to copy word by word the Wikidata infrastructure here. We are trying to really be as close as possible to it. And that's why the dumps look like this. There is a query service available. The query service is available under query.knowledgegraphconference.theqacompany.com. And also here, we really follow literally the Wikidata infrastructure, because the query service of Wikidata is under query.wikidata.org. The query service looks like this. So it looks like the Wikidata query service. And we saw that Q1 is the Knowledge Graph Conference. And yes, here are the triple that are corresponding to the entities that we were seeing before. And also here, it is really like in Wikidata. So in Wikidata, you would prefix everything like WD 2 points. We just override this prefix. So when you know Wikidata, then you know this thing. Another thing is that, which I think is very important, so in generally in a knowledge graph infrastructure, you have reified statements. So you have statements about statements. And this is generally not trivial to model. So if you want to model Italy, capital Rome, that's easy, 1 triple. If you want to model Rome is the capital of Italy since a certain date, then it gets already a bit tricky. And Wikidata basically imposes on you a data model to model this type of statements, and you do not really have to care about. You get it out of the box. So Wikidata, or this Wikibase ecosystem, basically gives you a very specific data model to follow that is very established, that allows to model things like reified statements, things like references, things like quantities, all things that if you would have to put up your own knowledge graph infrastructure, you would have to care yourself. Yeah, maybe also what is somehow nice about this Sparkle endpoint is that, not this thing, is that you have auto-completion. So here we are searching for a property. So it's a knowledge graph conference founded by, and then you can get your query result like this. This is something that is generally not integrated in a normal Sparkle endpoint, which is very handy and basically emerged because if you have 10 million users a month that are doing this, then you need something like this. Okay, so this Wikibase instance exactly tries to mimic Wikidata, except this thing. We call it Wikibase Sync, and the reason is the following. Imagine you have a domain and you want to create a knowledge graph about a specific domain, let's say pharma. Then basically the concepts that you need to model this domain are not all new. In fact, most of these concepts are in Wikidata already. The concept of clinical trial, the concept of drugs themselves, paracetamol you will for sure find, properties like participant, properties like location. So you do not want to reinvent all these knowledge. It is already in Wikidata, so you would like to reuse this knowledge. First of all, because it makes your life easier, and second of all, because this is a bit the principle of linked open data, that we reuse concepts basically that are existing there in other ontologies. So, you know, I have to think. So we want to, just a second, which concept we can use? Can someone name me some knowledge graph technologies? Something like OWL, but something maybe a bit more.
Onto your mail.
Sorry?
Onto your mail.
Onto your mail.
UML, yeah.
UML. This one? Unified Modeling Language, Software System Design Modeling Tool?
Yeah.
Exactly. Thank you very much. So let's say we have a talk at this knowledge graph conference which is about UML. So why should we reinvent UML if UML is in Wikidata? So if we search on Wikidata, we find also the University of Massachusetts, whatever. But basically, we want to reuse this concept of UML, and here we are. We have basically cloned the concept of UML from Wikidata in this knowledge graph, and it's ready to use. So now we can use this concept to basically say, for example, a talk at the knowledge graph conference, subject of UML. We do not have to reinvent this concept, and what is even cooler is that now this concept is expressed in many, many languages, which we would never have done by ourselves. And we have a link back to Wikidata. So if we go back to Wikidata, to this entry, then we see UML. And there is plenty of information about this concept. What we can also do is that we can sync this concept, and basically what will happen under the hood, if we go to the recent changes, then we see that a series of entities were imported, like the object management group or the property official name. And at the very end, there is this edit on UML, where basically maybe we can go just here, where basically all the statements about UML were now cloned in this local Wikibase. And now we do not only have the concept with the labels, but we really have all the statements about this concept. And like this, we are basically enriching our local knowledge graph. There are two aspects here. One is that basically what could happen is that in Wikidata, the knowledge evolves. So there are some editors that are changing the knowledge, and we would also like to have it here. So what we can do is that there is this sync functionality, so that if statements change in Wikidata, we can transfer the statements back to our local Wikibase. And this in particular means that part of the editors of Wikidata are maintaining our knowledge graph, which is cool because we have to do less work. One use case which we have for this and the EU knowledge graph is that we sync countries. So, for example, in Italy, there is currently as a head of state Sergio Mattarella, and if he dies or if there is a new election, this head of states will change, and someone in Wikidata, because it's a crazy community, will immediately go there and make the change and put the new head of state, and we do not want to maintain this, but with this, we basically can just copy over the new knowledge, and someone is maintaining for us this piece of information. And this is what we do. So we basically monitor all the recent changes on Wikidata, and we check, oh, this entity is linked to an entity that we have in the local graph. And when this is the case, we copy over the knowledge. The second thing is that basically what could happen is that we edit something locally, a statement, but in Wikidata, someone writes the opposite. And of course, this is something that we do not want because we know our knowledge. And basically what happens with this tool is that local knowledge has always priority over Wikidata's knowledge. So basically our local knowledge will not be overwritten. Maybe as an example, we can go here to the unified modeling language in Italian. This I don't know. In French. Where is French? Finnish. UML. Yes, okay, let's say we want to put as an alternative label UML diagram. I think it's fine. We publish this on Wikidata. We go back to our local knowledge. In French, basically, this is not appearing as an alternative label. And then we sync the label. And in French, this new label appeared. This Wikibase Sync can also be used here when we add a statement. So let's say we have something to add about Twitter. And currently, locally, we have the Twitter username, the Twitter user numeric ID, but we do not have the Twitter moment ID, whatever it is, identifier of a moment feed on Twitter. And basically, we would select it here. This property would be cloned locally in the Wikibase, and we could make a statement about using this property locally, which we will not do. Okay. So this was about Wikibase Sync, and the last piece of this Wikibase infrastructure is OpenRefine. So OpenRefine is a tool that is, oh, thank you, a question.
Just show me about the sync. Is there any possibility to see basically the commit or in the process when I'm syncing what it wants to sync right now and what it doesn't? Because there could be conflicts where I'm wrong in my local, and I would really like to see this and really maybe have some human in the loop that is able to edit and say, okay, yeah, this is what I want, this makes sense or this doesn't, because that would be quality enhancement.
Yeah, I understand. No, it's currently not there, but yeah, it could be. So we have this on the data level, because when we do the process, we basically compute the diffs between the two entities. So we know which are the statements that would be added and are not added, or would be deleted and are not deleted, but it's not exposed to the UI currently.
Maybe that as an option. I know most of users probably won't use this, but as an option, it would be great.
Yeah. It's true. Thank you for the comment. Other questions? Yes, go ahead.
Just now you said that you calculate the distance between the difference. How do you calculate distance?
It's not really the distance, it's really the diff. So you have two statements. You know that each property is linked to each other. Each item is linked to each other. So we basically, it's like in GitHub a diff.
Like in Git?
Yes.
Okay.
It's like in Git a diff. And we also import only the diff. So if you go back to the history, then you will see that this edit just changed the alias in Wikidata. It's not that we erase the complete entity and re-import a new one. So we import only this part. Generally, in our setups, we have a special user, which is called Wikidata Updater, that makes this thing, so that you always know, oh, okay, this edit comes from Wikidata. It's not now the admin user who made it. Yes, there was another question.
How do you deal with data poisoning?
Sorry? Data poisoning. So basically, we somehow have faith in the Wikidata community in general. Of course, there are parts of the graph that you do not want to have touched. And these are parts of the graph that we do not sync, so we do not put together. And also, so for example, in the EU knowledge graph, it happens that for some reason in the EU entry of the on Wikidata, one of the member states is the Kingdom of Netherlands and not Netherlands. And this was really annoying, because we are basically pulling this data to construct applications on top. So if on a EU website now the Kingdom of Netherlands appears, not Netherlands, then it's panic, because it's a political problem. And so in this case, we basically edited this statement locally about the member states, and we know that they will be never overwritten. And yeah, like this, we stay safe.
Maybe a follow-up question. Is there a sort of catalog of the bots that are operating over different, like, can you tell like what areas that they are working within? And is there a way to set up like monitoring to say like, oh, I'm watching out for this bot because I disagree with what it's doing? Or...
On Wikidata.
Yeah, on Wikidata, not necessarily your local.
So I'm sure there is a list of bots. In fact, maybe that's a bit a side note. So there are many processes around Wikidata. So if you want to have a bot, then you have to create a bot account. There is a community process. You have to make a page where you say, this is my bot, this is his name, I'm behind it, this is what the bot exactly has to make. Then you make 100 edits. Then there is a community that checks, oh, are these edits right? If the edits are right, then they say, okay, you can go now, you can make your mass import. So there is a list of all the bots. You can check what are all the functionalities that they carry out. And if you want to basically follow a bot, you would go, as here in the recent changes in the local Wikibase instance on Wikidata, you would check all the edits that are made by the specific bot, and you could basically follow it. Otherwise, generally there are accounts, so we do not see this so much here. If you log in, no, in fact, you do not need to log in. If you go to the history and to a certain user, no. Okay, maybe I don't find it so quickly. But basically, there is a tab where you can see the edits done by one user, and you could check all the edits made by one bot. Strange that I do not find it so quickly. Okay, other questions? Okay, so the last piece that I wanted to add is OpenRefine. So OpenRefine is a tool that originally was developed in Freebase and went to Google. Then it was open sourced by Google. Now it is maintained by an open source community. And there is a tight integration of OpenRefine in the Wikidata ecosystem, but also in the Wikibase ecosystem. And basically, we have constructed, in this Wikibase instance, we have a connector to OpenRefine because it's a very useful tool if you have some data in JSON, RDF, or XML, whatever, on Excel, that you basically can use it to import the data. Okay, so now, knowledge graph, conference graph. So we want to model the knowledge graph conference graph. So we started already a little bit. So as I was showing before, Q1 knowledge graph conference, there we are, that's fine. So then, so also if you are in an organization, basically you go to Wikidata, you take the couple of concepts that you need to model your data, you import them, settle. Then the second thing that you would do is that you also want not to reinvent knowledge that is there, but this knowledge generally in an enterprise is in Excel sheets. Everything is in Excel sheets. So in this case also we got an Excel sheet. So in fact we got two Excel sheets. One Excel sheet was from the organizers, which gave us an Excel sheet about all the talks, or not the master classes, the talks at the Knowledge Graph conference with the presenters. They were not super sure if it is complete. Let's assume it is complete. We have a data problem there, like in every organization, so pretty standard. And the second Excel sheet was about participants. So I thought the Knowledge Graph conference should contain participants. So where to find a list of participants without breaking privacy laws. So on LinkedIn, there is an account of the Knowledge Graph conference. They made an event about the Knowledge Graph conference 2023, and people went there and say, I participated. Perfect, public data, no privacy. So we scraped this piece of data. And yes, so basically, here we want, oh, sorry, now I'm skipping my presentation. Some structured data lying around, use OpenRefine. So we go to OpenRefine. OpenRefine looks like this. And now we import this LinkedIn sheet. Hide, how does this work? Next. this we call LinkedIn CSV. So here you see you can upload whatever you can think of in, you can Excel sheets, CSVs, JSONs, blah, 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 blah. We are creating a project. And yeah, this is how it looks like. Maybe let's quickly look over the data. So we have the full name of the person that said it will participate to the event. There is the LinkedIn ID of this person. Some people are struggling a bit with their sites, I see. There is the first name, there is the last name, there is an image. There is their title, Tenure Track Assistant Professor at KU Leuven, location Leuven, degree is the connection of degree in LinkedIn for me, but it's not important, and some other metadata that we do not care about. So I did this exercise already before. So yeah, so basically over time, people registered to this event. And at the very beginning, I already took some chunks. So some of these are basically already in the knowledge graph. But before doing this, I was saying before that some of these entities might already appear in Wikidata. And so we want to construct a knowledge graph about the participants, but maybe we want to reuse some information about these people that are in Wikidata. So what we can do is that we do reconcile, start reconciling. We pick the Wikidata reconciliation service, and we say start reconcile. So what this thing will do, it will take this column with all these entries. It will go to Wikidata and compare these entries with entries in Wikidata and try to make a link between both. And hopefully we basically find some QIDs that correspond to this entity. Okay, so here we see this little bar. So for part of them, we really found a Wikidata entry. For example, for Anastasia Dimou, she said she will maybe she's here, I don't know. She said she would participate to the Knowledge Graph conference, and here is her female, is her profile on Wikidata. So what we will do is that, now this is a bit, you need a bit to know the tool, but okay, edit column, add column based on this column. We call it Wikidata, and now I always have to Google this because where is this always hidden? Here. Okay, that's a bit OpenRefine hack, but be with me. So basically, we copied here the Wikidata QID because this is something we want to insert into the graph because we basically want to make a connection between these entities and the graph. But in fact, we do not want to insert these entities in Wikidata. So this is what we would do if we would insert these entities in Wikidata. We want to insert these entities in the knowledge graph. So we have set up the same thing. This is what I was saying before, a reconciliation service against the knowledge graph, about the knowledge graph conference, hopefully. We start reconciling, and yeah, so why we do this thing? So it's a very typical process. You have a piece of data lying around in an organization, and this piece of data might contain entity that you already have in the graph. So if you ingest them from you, basically you will duplicate entities, and this is not the spirit of linked open data. So as I was saying before, I imported many of them already before. So all this first chunk is already, they are already entities, and this is now the entity in the knowledge graph conference graph. Salvatore Avaglia, software engineer, DevOps at SRE, graph technology enthusiast. And before we modeled it as instance of human participant in the Knowledge Graph conference, and we have a Wikidata QID, which is this one. Maybe since we are here, we can check here in Wikidata what information we have about him. It's given name Salvador, position. Oh no, I think this is a wrong link, by the way. So this we will directly remove. Okay. Basically, maybe to say this. This is also nice. Basically, in this sheet, we find that Katarina Kari said that she would participate in the Knowledge Graph conference. And we found a concept in the Knowledge Graph, which is Katarina Kari 1@inteikea.com. And the reason for this is that in the other sheet that I imported, basically the entity was like this. And OpenRefine is proposing me, oh, this maybe are the same thing. And in fact, in this case, they are the same thing. So we say, yeah, please make this link and do not create a separate entity. And for all the rest, we will basically create a new item. Okay, so some of them we have reconciled. For some, we will create new items. Now we go here to this Wikibase extension. We say manage Wikibase instances. We use the knowledge graph as an underlying knowledge graph. And then we go to schema. And here now we can basically define how we will map this Excel sheet to the knowledge graph. So we will add an item, which is full name. This is basically the column that we will use to create new items. Then we add a term, and we say that the main label is in fact the full name, and is in English. Then we will add a statement, instance of human. And then we will say, how do we model the other data? Participant in. This is P80. Participant in Knowledge Graph Conference 2023. And yes, this is basically the, no, then we wanted also the Wikidata QID. Yes, then we check the issues. New items created without any description. So maybe we should add a description. Sorry? Yeah, true. And as a description, we can use the title. So if we go back to our Excel sheet, basically the title is this, and this is a good description for it. You can also say if this entity already exists, if we want to basically override the description of it. And then basically we would import this data into the graph like this, and this is what we do. We log in. Upload participants. Okay. And basically, if we go now to the graph, to the recent changes. Too many edits. That should not happen. Then we see that Hazel Alvador, our staff manager, was imported, and she has now an entity. And yeah, there she is. And here we basically will leave it importing a bit more. So what we have now in the knowledge graph is some contents about the knowledge graph conference. We have a subset of the participants. We have a subset of the talks. And now it's a bit open. So basically what So a participant looks like this currently. We should maybe have said instance of participant, but okay, we could change this. A talk, I don't know, someone has a talk tomorrow. Do someone remember a talk that she or he has tomorrow? I didn't check, in fact. Exploring the power of content knowledge graphs. Here, this is modeled as an instance of lecture. The presenter is Gavin Mendelssohn Gilson, and it's part of the Knowledge Graph Conference 2023. So, yeah, so basically now the discussion is a bit open. So the question is, what are things that you would absolutely have in the knowledge graph about the Knowledge Graph Conference? Topics, okay. So basically, you would like to add here the topics. Okay, this is maybe, I fully agree, cool. So I think there is a property called main subject. Now exploring the power of content knowledge graph. It's about knowledge graph for sure. Knowledge graph. Okay, so I think this is a way how we could basically add topics. And also very important here, as we saw with UML, basically we do not reinvent the topics. The topics are already there because they are in Wikidata. I think it will be rare that we have a topic that we basically do need to reinvent by our own. What are other things that you would like to have? Yeah.
Sorry, I missed the step where you got the initial data. Was that from LinkedIn or did you get that from the conference itself?
So there were two sheets that we basically used. One was about participants, and this one was from LinkedIn. So in LinkedIn, there is an event created, the Knowledge Graph Conference, and if you go there, you can say, I will attend. And this data is public, we scraped it, we made an Excel sheet, and this is in fact the Excel sheet that is importing here.
Oh, right.
That
So
should
the
be.
scraping part, is that like an API for LinkedIn, or is there another way to get it?
We used a tool to scrape it, which we use also for some marketing sometimes. Yeah, it's the easiest way I could get at some data. Yeah. And the second Excel sheet, the second sheet was given by they gave me yesterday this list of presentations. I can show how it was looking like. Ford. I don't know why it's called Ford, but it's Ford. It was an Excel sheet like this. Why is this so? So we had the name of the presenter, its employer. So again here, I checked in Wikidata if we can reconcile the employer. I added the QID if this was the case, so that we have basically some more metadata about the employer if it is there. Otherwise, I just invented the entity. The title of your presentation, short summary. There was also the long abstract, short biography. This I didn't do. And there is a track. I'm not sure if I imported a track. Yeah, so these were basically the two data sources that we used to construct this thing. What are other things you would like to have?
Maybe with the speaker.
Who?
The speaker name.
The speaker. In fact, the speaker of the talk is currently here. It's just called presenter. I think I reused a property from Wikidata. So yeah, maybe I didn't reuse the very good property from Wikidata now that I see it, but just for the sake of a speaker, we could say this is also speaker. Then we are more or less safe. Yes. Other ideas? Yeah.
I was poking around with the sync and saw that you'd already added ORCID IDs. So if you are a published author, you can associate your entry with your publications.
True. Yeah, it might be nice to point to ORCID. Maybe if we think after that, we want to construct an application on top. So, for example, the website of the Knowledge Graph conference could be constructed on top of this knowledge graph. And then basically, when I click on the entity about the presenter, then I see, oh, this presenter has also some external link, Twitter, Instagram, ORCID, and I basically can click on it, and it makes the website more interactive and maybe more useful because I have more metadata about this particular entity. Yes, please.
The technologies that the talk talks about.
What would be the difference for you between subject and technology? It would be a subset of?
Yeah, so for example, we've got lots of vendors of different like platforms and that sort of thing. Like you've talked here about like Wikibase and OpenRefine. Like somebody else might also bring up OpenRefine in a different context. That's all.
I didn't thought about it. That's nice. Yes, so that you can find talks more about from a technological point of view. Okay. Other ideas? Okay. So my ideas were, participants. This is more or less what we had. Presentation and talks. The location, the rooms would be nice to say, oh, there are 3 rooms. There is an online session. This is something that we do online. This room is at Cornwall Tech. It is in New York. Could be also something that we could model in the graph. Something I thought about would be interactions between people. Said, oh, I spoke with him. There is a connection between me too. One could create something like a graph of interactions at the Knowledge Graph conference. But okay. So maybe what I suggest for 5 or 10 minutes. Yes, so you can go to the graph, and basically you can try to search yourself. So if you're a presenter, you should be there if the thing was complete. If you are not there, you can. Yes, there is this. There is this new item link. There is this new item link, and basically you can create yourself. And otherwise, I don't know, you can either go to yourself and add, for example, which country you come from, which language you speak, or what is your subject expertise. And if you go to a talk that you do, you could add where it takes place, or so there is me here. There is also Jonathan with me. If you run into problems, yeah. Or some of you already tried some things. I don't know. Yeah.
Sorry, I already edited the
Okay.
added a location.
Maybe we can check here if something is happening. Okay, so.
There, you see my chain. One question, is there any possibility to do shackle validation or something? Because I used this and native language and said German, but I clicked on Germany basically, which is a false entity, and it would be nice to have some recognition that, okay, no, that doesn't match with the ontology behind it.
Okay, so for this problem that you said, there is a solution which I didn't install because it was already quite a bit of work to install all of this, but I can show you here. So this is the dev environment that we have. So do not look, it's the dev environment. So in this Wikibase instance, there is one additional extension that is installed, which is part of the Wikidata ecosystem, which is called Wikibase quality constraint or something like this. And basically, on a property level, you can define something like the range and the domain. It's here. It is in the data. It's called property constraint. Allow qualifier constraint property. No, wait a second. Value type constraint. So this is basically the constraint that you have on the object for the property country, and it should be a sovereign state, client state, occupied territory, blah, 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 blah. The nice thing here is also this, we didn't invent, this comes from Wikidata. So Wikidata editor already basically defined the domain, the range for this particular property. And here now currently it's Japan. I'm not sure if this is the right one. Okay, and if we go edit Japanese, then I will get this. I said, oh, no, that's neither a sovereign state, nor a client state, nor occupied territory, nor disputed territory, or whatever. It's a bit crazy. Ancient Chinese state, whatever. So this is one way the community is basically tackling this problem. And but what is missing is something like real shackle. So something that we would like to see is that you go to the page, you say this is an instance of presentation, and then there is something like a form and says, for presentation you need to input this, and this. This is typical shackle, and this doesn't exist yet. And yeah, hopefully we'll see this in the future. Yes, so maybe we can check here, Will Langdale created an entity, conference attendee, instance of human. Maybe I add here also participant in knowledge graph conference 2023. Yep.
That's interesting because I've just added something slightly different. How's it going to reconcile the two?
So to the same entity?
Yeah. Yeah, there you go. Okay. So.
Which is good. I think both pieces of information are right. He participated at a special edition, but at a knowledge graph conference in general. So I think it's a fair data modeling. Okay. We have Canada, who was imported. Wow. And France, because probably someone of you is coming from there. Tim Amstein. Okay, native language German. Yeah. Okay. There are some other questions about this part. Yes, please.
Sorry, when you want to add a new entity, is it just like in Wiki where you just get a new?
Yeah.
Or is there a place you're supposed to go?
No. So to edit a new entity, there is here I put the link, new entity. You do not have it? Yes, strangely, I was checking here that here in my online presentation, it's also missing. It's a bit strange, but you can go to special pages. I'm also confused. You go, so in fact, all the, there is this section, Wikibase, these are all basically operations. And there is create new item, create new properties. You can also list all the properties, and there are a couple of other things that you can do.
That's what I was
one question, is there an open API or something that I could use to, for a client, maybe I don't have this this interface, but really create their own web page, but in the background I have this system. Do I have an open API to channel and do all this stuff via?
Yes. In fact, the Wikidata ecosystem is pretty big. There are clients for Java, JavaScript, PHP, Ruby, Python. We generally use PyWikibot, which is a Python binding for doing most of the operation that we do on large quantities of data. Okay. So we have 12, 15 minutes left. So the last thing that I want to briefly, I think this finished. Yeah, these are some entities. Okay, I promised some QA, so let's do some QA. So the thing that we were doing, yeah, maybe one. So we constructed a knowledge graph. So what we could do with it, we want to construct some application on top. What I was discussing would be basically to make a website, to basically feed the website that we have about the Knowledge Graph conference with this graph. This could be one application. This is something that we do for the EU Knowledge Graph. We basically feed a website using it. Another application could be basically to trigger search. Yes, so basically, while you were editing, there was a connection between this Wikibase instance and this instance about question answering system, which is QAnswer, which is something that we create. And basically, we find entities that are in this graph. So if you search about this entity, then we would retrieve it with the corresponding metadata information. Three participants. Okay, so here if we ask the participants of the Knowledge Graph 2023, we would get basically all the entities that we have currently ingested. Yeah, here we see that there is some problem in the data, which was maybe not so obvious before. But what I want to say is that these entities really come from the graph when we basically ask for questions. And who founded the Knowledge Graph conference? This is also a statement that we see before. So basically, we can use the graph to trigger a search. This is one opportunity. And yeah, to add some other QA. So basically, generally, structured information is a good place to basically host structured information. So knowledge graphs are a good place to host structured information, but they are not a good place to host unstructured information. And generally, when we do QA, we have a combination of data that is both structured and both unstructured. So what we can do is that when we go to the Knowledge Graph conference, for example, we have this FAQ section, and here there is some unstructured information about the Knowledge Graph conference, which we can print in a PDF. And then we are basically making a question answering system over a document, Knowledge Graph conference text. We take this PDF that we just uploaded and we index it. And then we could ask something like, what is the hotel for the Knowledge Graph conference? Let's see. And now we have question answering of free text. The conference preferred hotel for the Knowledge Graph conference is the Graduate Hotel Roseland Island. What are the main topics of the Knowledge Graph? Knowledge Graph. He understood it. During Knowledge Graph Constant 23, there will be multiple parallel tracks covering a multitude of topics related to knowledge graph technology, including data architecture, graph, neural networks, natural language processing, and so on and so on. And we have the reference where basically this data comes from the source, which is basically the PDF that we just extracted. And now, yes, so we have our structured data, we have our unstructured data. So we basically combine both in one question answering system. And now we can ask who founded the Knowledge Graph Conference. And we would get the answer over the graph, or Dennis. We would get this information, or no, probably this interpretation. And we can also ask, I have problem subscribing to Knowledge Graph Conference. No, subscribe. Okay, no, that's maybe not written in this FAQ. What is written there? Maybe we can check. I know. Is Knowledge Graph Conference an online conference? Ooh. In fact, I wanted this answer. No, Knowledge Graph Conference 2023 is a 5-day hybrid conference with multiple parallel tracks every day, which the final day, virtual Friday, will be virtual only. Yes, that's it. Yes, I'm open for questions.
I know you go for it.
Okay, just curious. So I tried to add my sessions. I found myself in the knowledge graph that you showed, and I tried to add my session, which was yesterday.
Yes.
So I added a new item with the title, and I added the description, and I added myself as a presenter there.
Yes.
So could I ask the question in? Okay, like, what is Adam presenting? Like, I could add the session as an instance of something. I'm just curious, like.
How? Adam, how are you spelled?
Let's see if it finds me.
I think you need to model, if I'm correct. Adam. Oh, this, by the way, is not so good. This here is, let's see, in fact, this connection. Yeah, it would help. In fact, sometimes I didn't check now this morning if this process was still running. So maybe we have just the data of, there we have your. Yeah, then probably, I think the update process is either slightly delayed or it is broken. I didn't check it this morning. And so basically we have the data of yesterday night.
And I saw that you added IKEA into IKEA Holdings. If I would ask the question, is there any presentations made by IKEA?
It depends a bit how the model, the data is modeled. So if it is attached directly to the talk, yes.
Oh, okay, yeah. So it doesn't jump. It doesn't hop.
Doesn't jump currently, yeah. Okay, other questions?
Can you ask us something in non-English?
So for the free text part, yes. For the knowledge graph part, no, because I indexed it only in English. But yes, so basically, if the knowledge is expressed in non-English, then yes. Yes.
It's related to the language question. There is any combination of different languages, for example, if something is in English and something in Germany, so there's a mixing up, or?
We generally separate by language. So we generally separate by language. So we index German-only content, English-only content, French-only content. We do not mix.
So if some content is in specific language, so in another language, it may be a bit different, or in one language will have more information than the other language.
Yes.
Okay.
Yeah. Yes, please.
Sorry, I came in late, so I might have missed it. But like for the answer summarization, are you using a generative model to generate the answer?
Yes. But it is backed up by the document that we provide. So we do not. There was no. I cannot summarize this answer. This means that. Yeah. So generally, a generative model would just output whatever. That sounds very good, but warm. In this case, it is backed up by the document that we uploaded.
And the follow-up question: so how does it know which part of the corpus that it got the answer from? I noticed like at the bottom it has like references.
Okay, that's internal.
Okay. So the secret sauce of it.
Yeah, let's say so. Okay. Yes. That's it from my side. Please.
Sorry, it may be maybe not relevant to this last part, but yesterday we talked about classes and instances.
Yes.
I'm just curious, I see that a lot in the Wikidata. It's like an instance of a human, an instance of something, instance of a something. Is there a way that I can see the instances, all the instances of something? Like human obviously will be hard, but let's say, well, what if I want to see a list? Like, is that possible to see through Wiki?
The list of instances of something.
Yeah. So for example, if I click on
all the sessions organized by date and time.
Sorry?
All the sessions organized by date and time.
Whatever. If there is an instance of something in the UI, when I click instance of session or instance of human, I click on the human part. I just.
I don't think in the UI itself there's something built for this.
Okay. But you can query it.
Yeah.
Okay.
You said organized by date and things. In the UI of the QA, you don't have different endpoints. You have different views that can be used to display the query. And it can be, you can make it directly in the Sparkle, and that's how you show the graph view. It's some result in this that is built in the.
Yeah, so in the Sparkle endpoint comes with visualization. So if the data fits, you can make out the map out of it, the line chart, the bar chart. The graph is the thing that we were showing before. Yes, so you can query it. Generally, this is also something I didn't prepare. There are example queries, so you can underlie example queries. You could say, I want all my participants. It's a query that is underlined there so that people do not rewrite it. And to the discussion yesterday about instances and classes, in fact, in Wikidata, there is no difference. An instance is a class. A thing becomes a class just because someone says instance of something. And in fact, you had this discussion, what should be an instance and what should be a class. I find it something relatively unnatural because then there are discussions, oh, should I put this in the ontology? Should I put this in the data? In Wikidata, this doesn't exist. Everything is part of the data. Everything is an instance. So if something needs to be a class, you just say instance of, and then it becomes a class, and you do not really care about this problem.
Just another triple.
Just another triple, yeah. There is no strict separation between ontology layer and instance layer. Okay, thank you very much for your attendance. Wish you a nice conference. See you around. And yeah.